Okay, today's experiment comprises of several different parts, so you need to make sure you're as prepared as you possibly can be. We're going to start with the recrystallization. You've got some work to do the minute you set foot in the lab. Your first job is going to be to get this setup completed and to start the heating process before we have our prac talk. Take a beaker of water, doesn't matter exactly how much is in there, and place that on the hot plate under a clamp. Take a conical flask and suspend that above the beaker. It should be just above the water level. Take a sawn-off funnel and place that in the top. Collect a match and break off the tip of the match head. You don't want that falling into where your crystals will be later. It can discolor them. Then take the match and bend it. Don't break it. So just a gentle bend like so. And then place that under the funnel, between the funnel and the flask. This allows air to get in and out. Take your impure sample for recrystallization and put it into another clean conical flask. And then, using a measuring cylinder, add approximately 40 ml of distilled water. This will be the solvent used to dissolve your crystals. Place that on your hot plate. Finally, collect a beaker, add some extra solvent that you'll heat up, and pop that on the hot plate as well. Turn on the power to the hot plate and turn up the heat. And then once you've done that, you can let it sit for a while, wait for it to come to a boil, and come and have your prac talk. Once the prac talk's done, you'll need to construct a fluted filter paper. You can get assistance from your demonstrators on this task. Pop the fluted filter paper in the funnel so that it warms up. And then once your sample has started boiling, you'll need to carefully add hot solvent until you're convinced that you've just dissolved all of your acid analyte crystals, but none of the other insoluble impurities. Once you think you've reached that point, collect some more hot solvent and add approximately 10% more volume to that flask to ensure that all of the acid analyte is dissolved and remains dissolved. Try and use that solvent to wash down the walls as well to make sure all of your analyte is in the flask. Then, using tongs, use an upside down grip to pick up the flask. It'll be more comfortable that way when you're pouring. Hold your glass rod over your fluted filter paper and then pour as low down as you can down the glass rod. Obviously be very careful at this point in time. There's a lot of hot equipment involved. I don't want you to burn yourself. Continue to carefully pour until you've poured off all of the liquid. There will be some insoluble impurities remaining behind. That's okay, as long as there are no crystals growing. You may see some crystals forming in your fluted filter paper. Take some more hot solvent and run that through your filter paper in order to dissolve those crystals so that they end up in your filtrate. Once the filtration is complete, you can turn off the heat, take out your funnel, make sure you take out the matchstick with it, and then elevate your flask with your filtrating crystals so that they can slowly cool down. Then leave these to slowly cool over a long period of time, at least an hour. Doing this will promote the growth of larger crystals. While that's happening, you can either move on to your distillation or your melting point study. First, the distillation apparatus. When you're putting this equipment together, make sure that the joints all fit snugly and you can use Vaseline to help seal them if need be. Start by clamping the condenser into place at approximately the right position. You can adjust this later on, so don't be too fussy. Attach the receiver and use a yellow clip to make sure that receiver is held firmly in place. On the other end, attach your still head, and again use a yellow clip to ensure that it is securely attached. Collect your round bottom flask and pour in the 30 ml of your sample that you'll be distilling. Very important safety step, make sure you collect some anti-bumping granules or boiling chips and place them in your sample. You only technically need one boiling chip, so 2 or 3 chips is plenty. That will ensure that you get smooth boiling, you won't superheat your solution and won't cause yourself personal injury. Attach the round bottom flask to the still head, use a yellow clip to make sure it's held firmly in place. Pop a sample collection vial under the receiver and then adjust the height of your entire apparatus such that the tip of the receiver is just below the height of your sample flask. Once that's all in place, you can bring over your heating mantle and use an adjustable platform to adjust the height so that it snugly fits around the round bottom flask. Get your thermometer and place it through the still head. You want the tip of the thermometer to be just below the height of the sidearm, ever so slightly lower, like so. Now for the plumbing, to ensure that your condenser stays cool, first of all, connect one piece of tubing to the tap and then connect the other end of that to the bottom end of the condenser. You want the water to go into the bottom of the condenser and then fill upwards. Then collect your second piece of hosing, attach one end to the top of the condenser, and then channel the other one back into the sink so that it runs back down the drain. That is your distillation setup. It should be good to go. Don't turn on the power or water until you've checked over this setup with one of your demonstrators. Once they've given you a safety okay, you're then okay to proceed with the experiment. Adjust the heating to about 5 or 5.5. It's appropriate for this experiment. Make sure a waste beaker is in place to collect sample until you get about 1 drop a second. Then you can swap in your collection vial and collect a few mils of your sample. Once you've got a few mils of your sample, the amount in this video is more than enough, you can then swap it out for your waste beaker and turn off the heating. You'll then need to take your sample and measure its refractive index. Further instruction on this procedure will be given to you during your lab session. The other part of your experiment involves the determination of the melting point of a series of unknown samples. You will be provided with 3 samples, 2 with their unique identifications and a third one that's a 50-50 mixture of the first 2 samples. Your job is to determine the identity of these samples and whether the 2 individual unknowns are the same material or 2 different chemicals. To use the melting point apparatus, follow the instructions provided. To collect a sample, simply remove the cap from your sample, take a capillary tube and invert it upside down. In your sample, you only need a very, very small amount. Then collect a file and just run the file very lightly along the outside of the capillary tube. The vibrations will cause your sample to slowly slide from the top down into the bottom of the capillary tube, which is where you want them for your analysis. You can then load your sample into the side of the melting point apparatus and proceed to follow the instructions to measure the melting point. You have the capability to measure the melting point of 2 samples at once, so I suggest you take advantage of this. Make sure that you keep your ramp rate, your increase in temperature, below 5 degrees a minute at all times and below 2 degrees a minute when you know you're close to the melting point of one of your samples. By the time you've finished your distillation and melting point determinations, your crystals should be ready for filtration and separation from other contaminants. Use a vacuum hose to connect a filter flask to the sidearm of a tap. Then use some foam insulation and a small Hirsch funnel with a small filter paper and load that in place. Turn on the water in order to achieve a vacuum. And then pour your sample slowly through the filter. Once the filter paper is completely wet, the vacuum will take over, and you can then continue pouring your crystals through. You can use a small amount of water to wash your crystals, and then leave the vacuum running for an extended period of time to help dry your crystals. Once you've finished the filtration, disconnect the hose from the sidearm, then turn the water off. And then take both your crystals and your filtrate for your demonstrator for assessment. When you finish up today, think carefully about what you've been handling, make sure waste goes into the appropriate receptacles. And a final reminder, make sure you come ready and understanding all of the key concepts today, as you'll be required to write up the experiment before you leave the laboratory. If you've done some pre-preparation and thought about your write-up and calculations before you arrive, you'll be in a much better place. Hope it goes well. I'll see you soon.